Okay, today we're gonna discuss lab 6, which is to use for loop to iterate. So let's start with a very easy sample code. So again, you are given our favorite examples of quiz, which contains a list of score for each quiz. And quiz 0, for example, has score 5, quiz 1 has score 3, and so on. So we start counting from 0. And you are asked to run a for loop to display the score for each quiz. Okay, so first we're going to execute this. So the quiz is a variable that is defined, and then we run a for loop. So for score in quiz, okay, you're going to print score. So we can run a for loop to display the score for each of the quiz. So when you do that, you basically display every score one after another in a new line. So if you want to tell the user which quiz get which score, then we're gonna iterate over the indices. Okay, so we're gonna use what we have learned, which is range. Okay, which takes two values, start and stop, and it generates integers from start to stop, but exclude the stop value. Okay, and if start is omitted, that means you do not provide the start value, then by default, start is 0. Okay. So we're gonna do that. We're gonna run a for loop over the indices of quiz. Indices will represent the quiz number. Okay, so now instead of for score in quiz, right, we're gonna do for I in range length of quiz. Okay, so this will generate range length of quiz will generate integers from 0, 1, all the way to length of quiz. It doesn't include the stop value, so this is a stop value. We omit the start value, so by default it starts with 0. Length of quiz -1. So it will include length of quiz -1, exclude length quiz itself. Okay. So for I in range, length of quiz, we're gonna print quiz I has score, which we're gonna retrieve it using the index. All right. So first is quiz I. So this is a placeholder that will replace with the value of I. And here it will replace with the score of the corresponding quiz I. So that will be quiz with a square bracket I. Okay, this will retrieve the I index, the value at index I of quiz. Okay, index here corresponds to the quiz number. Right, so here we will have, for example, quiz 0 has score 5, quiz 1 has score 3, and so on. All right, so this is something you have studied in the lecture. Now, as an exercise, you are asked to run a for loop to display a ticket sales of each day, where you are given a day sales variable, is a variable name, with a list of number. So each day you record down the number of tickets sold on that day. So there are 7 days, all right? And we start counting from day 0. So this is day 0, day 1, 2, 3, 4, 5, 6. In total, there are 7 days if you count from 0. And now you are asked to run a for loop to display the ticket sale of each day so that you have this as output. Okay, so the same as before. All right, you use a sample code. Now for I in range length of something. Okay, so you need to complete this. So this is to do. So you need to complete this in range of what? Okay, so complete the following code. So the length of what you want to iterate over with. So in this case, it will be day sales. All right. For each one of them, you're going to print the meaningful messages that is in day I. Okay. How many tickets also. All right, this is for you to fill in. Okay. So in day I, what will be the corresponding index? Okay, so this is to do. So instead of quiz I, now you are trying to retrieve the value of index I of not quiz, but day sales. Okay, so this will be this. Okay, so this is for you to do and complete. All right. Now, let's look at this sample code here. Again, you will use back at the example of quiz score. Okay, and we'll ask you to run a for loop to display display the score for quiz 1 to quiz 5. Okay, so early on, our quiz start from 0. So you run quiz 0 all the way to quiz 10 because there are 11 quizzes. Okay, now I ask you to just display quiz 1 to quiz 5. Okay, we don't have to display quiz 0. We don't have to display quiz 6 to quiz 10 onwards. So this is easy. All we have to do is to change this part here. Okay, instead of generating integers from 0 all the way to length of quiz minus 1, we're going to generate integers from 1 to 5, include 5. Okay, include 5 means generate integers from 1 to 6, but exclude 6. Okay, remember your range functions, all right, will have a start value and a stop value, and it will generate integers from start to stop, but excluding stop. So this is what we're going to do. We're going to change this part here to start from 1 all the way to 5, but exclude 6. Okay, so this will display quiz 1 score all the way to quiz 5. Does not include quiz 6. Okay, now as an exercise, we use the ticket sales example and run a for loop to display the ticket sales of day 0 to day 4. So here is your previous code. Okay, now you're going to change this. What is the start value? What is the stop value? All right, so remember you want to generate integers from 0 to 4, include 4. Okay, means generate integers from 0 to 5, exclude 5, all the way to until 4 only, because we only concern day 0 to day 4. Okay, so this is for you to do. Now, let's consider the quiz score example again, and you are asked to display one quiz number with score equals to 5. So you have learned how to do this before using dot index. Okay, so recall the dot index method. Okay, which takes a value as an input. We take a value, say x, say dot index x of some list L, which take a value x and return the index of x in L. All right, so it apply on the list L. In the bracket, you input one value x. So when you execute this method here, it will return the index of x in L. Okay, so if you're looking for what is the quiz number, remember quiz number corresponding to the index. So recall that quiz number is the index. Okay, each index corresponds to a quiz number. So we start with quiz 0, quiz 1, and so on. So we want looking for essentially when we want to display one quiz number, we display one index with score equals to 5. That means we're looking for the value of 5, take a value 5 and return the index of 5 in quiz. Okay, so here, execute this quiz.index 5. So that's the quiz number with value with a score 5, which is quiz 0. Indeed, quiz 0 actually has score 5. Okay, so quiz index, if you recall, can do help. Index is it return the first index of the value. Okay, so it return only one. Okay, what if we are interested with all the indices or all the quiz numbers? So all the quiz number with score equals to 5. You can't use dot index because it return only one. So we want all of them. We want to display 0, which has score 5. We want to display 0, 1, 2, 3, 4. 4 as a quiz number that has score 5 as well. And also the quiz number or the index of this 5 in this quiz here. So in this case, we're going to do this using for loop. Okay, if you want to display all such quiz, we're going to do for I in range. Again, we are running through the indices of quiz. Okay, because we will require to know what is this I here, which this index, this represent the I. We're running, we iterate over the indices of quiz. Okay, so this means iterate over indices of quiz, okay, which is 0, 1, all the way to length of quiz minus 1. Remember the last index of quiz is length of quiz minus 1 because we count from 0. All right. So for each one of them, for each index I, okay, I'm going to check if quiz of I is equals to 5. Okay, if it's so, I'm going to print quiz I has score 5. Okay. Right, so let's run this code here. It says quiz 0 has score 5, quiz 4 has score 5, quiz 8 has score 5. So incorporate if statement inside our for loop. So in our if statement, we check whether the value of quiz at index I is it equals to 5. If it's equal to 5, we print it. All right. So this will display all the quiz number with score equals to 5. Now, suppose you are asked to, for example, display the quiz number and the corresponding quiz score for those quiz score that is less than 3. Okay, so this is a slight modification from before. Instead of equals to 5, we are looking to less than 3. Okay, head score. Now, it asks you to display the quiz number and the corresponding score. So it's not just has score less than 3. We also need to display the corresponding score as well. So we're going to display the quiz number and the corresponding score for which the score has less than 3. So it will be I here. So quiz I has score, that will be quiz I. Okay, so this is just to retrieve the value of quiz at index I. So those that are less than 3 will be displayed. Those that are not less than 3, those quiz score that has no that is not less than 3 will not be displayed. So we display the number, quiz number, and its corresponding quiz score. And as you can see, 1 to 0, all of them less than 3. All right. Now, suppose we're interested in those quiz number and their corresponding score for which the score is less than the average score over all quizzes. Okay, so I'm gonna have the similar code. So it must be less than the average score. Okay, so here is a less than the average score. So what is the average score? Now, you don't compute it yourself. So this is your quiz. Okay, don't compute it yourself and put the value there. Instead, we're gonna write a statement or execute a code to compute the average for us. So if quiz is less than average score, then we print the quiz number and its corresponding score. But what is the average score? So we need one more step before the for loop to compute the average score. So average score is equals to Now, if you remember in I think lab 2 or lab 3, we talk about how to compute average score. So the average score is the sum of all quiz scores divided by the number of quiz. Okay. So here, the sum of all quiz scores, remember a quiz is a list, so you can use the built-in function sum of quiz divided by the number of quiz. So we have the number of quiz is length of quiz. Okay, so let's run this. Okay, so these are all the quizzes with score less than the average score. All right, so you can even print out what is the average score, for example. And for example, print the average score is just average score. Okay, so the average score is this 3.1818 and so on. And now when you run the for loop, those quiz score that is less than 3.1818 and so on will be displayed with its corresponding score. For example, quiz 1 has score 3, which is less than this number, and so on. Okay, so as an exercise, again, we look back at the example of ticket sales. Okay, so first you are asked to display the day and the corresponding number of tickets sold for each day, which number of tickets sold on that day is less than 30. All right, so let's go look at our previous code here. Which is here. Okay, so let's see with you. So for I in what? Okay, so here I'm gonna give it to you. For I in range of length of ticket sale. So make sure I create the right variable. So the variable is day sales actually. Okay. So the variable is day sales, so range of day sales. Okay. So these will iterate over each day. We start the day counting from 0. And then you're gonna write an if statement. So to do, write an if statement. So the following is to do. Complete the following code. Okay. So if what? If certain number, which is a cell of that day, so it will be day cell square bracket I is less than 30. Okay, then you will display the day and the corresponding number. So you will print, I'm gonna use the previous print statement, which is print day I has number of tickets sold. Okay, so the number of tickets. So okay, so again, use dot format, and this is for you to fill in. Okay, this is to do. All right. So this will be I. Day I has what is the number of tickets sold? That will be day sales square bracket I. But you must make sure you have this if statement. Day sales square bracket I is less than 30. Okay. Now exercise 2B. For each day, which the number of tickets sold on that day is less than average tickets sold over a week, display the day and the corresponding number of tickets. So basically the same as before, okay? Except that this is no longer less than 30. It should be less than average ticket, okay? But what is average ticket? That you need to compute yourself, okay? So this is for you to do, okay? So average is the sum of day sales divided by the number of days, and we have 7 days. Okay. Now sample code 3, we're gonna look at the user input. So you're asked to create a program to get user to input a new password. You will display a message to verify if user password is valid. A password is valid if it contains a digit, and you are asked to do this by running a for loop to complete the task. Now, previously, we have learned how to do so using different methods, such as using set. Okay, so let's first ask user for input. Okay, so input, enter a new password. Okay, all right, and then say for whatever password is. Okay, you need to run a for loop to complete the task, which is to display whether the user input is valid. And you must make sure to be valid, it must contain a digit. So for example, there are multiple ways. The previous way that we have learned to do it, for example, is to check whether the set of digits intersect with user input. If there is an intersection, means at least one of the digit is also in user input. Intersect means those that are in here and in here. Okay, and the way we do it is we check whether the length is greater than 1, greater than 0. Okay, so this is attempt 1. So without using for loop. Okay. Alternate solutions without using for loop. This is one alternate solution without using for loop. So if the length of the intersection of them, okay, I want to check the method for intersection, just to be sure. So it's intersection, right? So intersection user input. So I want to check this. I want to check the intersection of this set with user input. I'm going to make it into set as well, right? This will return a set that contains element that in both set is in here and in here. If it's more than 0, that means it's not empty, means there is an element in both this set here and this set here, which means there is an exceeded digit. So if the length, so we're gonna do intersection. If length of this is greater than 0, okay, then we print. Here it means check if the intersection of set 0, 1, 2, all the way to 9, if there exists intersection element in set this and in user input. All right, then you print the new password is valid. Else print new password is invalid. Right. So this is a solutions that use a new data structure, another data structure called set, to look for the intersections between user input and all the possible string of string of digits. And if there is intersections, means their length is more than 0, then you print that the password is valid. Otherwise, it's invalid. Okay, so this is a solution not using for loop. The downside of this is that, okay, however, this solution it's not necessary. It's doing more than necessary, because if there are multiple, say multiple digits that is in the user input, all right, it's actually do the intersections of these multiple digits here. So the intersection will have 1, 2, 3, 4, and 9. Okay, and so the length is definitely more than 0, but it also compute all the possible digits that are available in user input. Okay, so it computes all the possible digits in user input, which is not necessary, because we only concerned with whether there exists one. We don't care which one, okay? Or how many are they? As long as there is one, we don't care which one, we don't care how many are they. As long as there's one, that's all we need. In fact, you don't need all these intersections. We just need to know whether there exists one. We just need to know whether the length is greater than 0. So computing the intersections is a bit unnecessary in my opinion. So let's do a different way where we run a for loop, okay? So let's run a for loop instead. So let's run a for loop, okay? Let's run a for loop over all the digits, okay, and check, and in each iteration, check if the digit is in user input. All right. If yes, so if the digit at the iteration is in user input, we found one digit, and that's all we need. Okay, we don't care what digit is it, as long as we found one digit, and we are good. So we're gonna break the iterations. We don't check anymore. Okay, we don't check that whether there is subsequent digit that is in there. We just break the iteration. That means we stop checking. All right, so we stop checking. And before we stop checking, we need to tell the user that print. You can, for example, say, you can say is valid, set is valid is equals to true. Okay, so if not, if at the iteration the digits is not in user input, continue with the iterations. Okay. Now, before you do that, you must make sure that the is valid is defined. It's a variable that is defined. Okay, so once you exhaust all the possible digits that you can check, okay, so if at the end of the iterations, none of the digit is in the user input, that means there exists no digit in user input, so the new password is invalid. Right. Now, for that to happen, which means that we need is valid to be false at the beginning. Okay, so we want to make sure. So let's initialize. First, initialize is valid. to be false. Okay, it's false until we prove that there is a digit inside that user input. Okay, so we're gonna set it to false at the beginning, and you run the iteration. In each iteration, we check a digit whether that digit is in user input. If it does, if yes, you already found it, you set it to true, and then you break the iteration. You stop checking. If not, you continue. At the end, if none of the digit is in user input, that means that there exists no digit. So the new password is invalid. That means it's valid. It's never changed to true. It remains as false. Okay, so this is the idea behind our following code. So for digit in all the digits, okay, and you're gonna check if digit is in user input, right? If it is, it's valid, it's set to true. And before that, you need to initialize this value equals to false. All right. And then you break. At the end, you print whether it is valid or not. So if it's valid, you print the new password is valid. So I'm going to copy here. Otherwise, you print that it is invalid. Okay. Print the new password is valid if it's valid, else you print the new password is invalid. All right. So here's the code. Okay. So this once you hit a digit that is in the new password, it will break. It will stop. Okay. So we don't do unnecessary things. For example, to find all the possible digits that are in the user input, as in this alternate solution here. Now, as in the lecture, I also show you that instead of writing 0 to 9 explicitly, okay, so improve code. So in the following, we improve the code by not writing the digits explicitly. Rather, we will use range, okay, to generate integers from 0 to 10, 0 to 9, okay, include 9. So we use range change. Remember range change, by default, you start from 0 all the way to 10, but exclude 10. So it will be 10 minus 1, which is 9. Okay, use typecasting to convert int to string, right? So here we're going to do, so it will be range of 10. Okay, and if string of digit is in user input, then we have this code here. Okay. Now, as an exercise, you're going to create a program to get user to input a new password as well. You will display a message to verify if user input is valid. And this time, it's valid if it contains at least one of the following special characters. So these are all the possible special characters. And run a for loop to complete the task. Okay, so basically it will be the similar as what we have here. So I'm gonna write user input. Okay, we're gonna have it here. You're gonna write this, right? And you're gonna do this on your own. So you complete the code. Okay. For what if what is, okay, and you set is valid is equals to what, and then you do the break, for example. Okay, so this is for you to do. So what is this? And what is this? So complete on your own. And if it's valid, you print the new password is valid, else you print the new password is invalid. Okay, so you can, so this is all you need. Okay, you need to type this. So I can, for example, write special characters. I store it as a string. Okay, so if you do that, okay, you realize that if I store it as a string, all right, and assign it to the variable special characters here, and when I execute it, it says that the special characters contains only one element, which is exclamation mark. Okay, so you're wondering, okay, why is that so? It's supposed to have this number of special characters, these possibilities of special characters. These are all the special characters that if one of them is in user input, then it should be valid. But if I put it as a string, the special characters, when it's executed, it only contains the exclamation mark. It doesn't contain the rest, which is supposed to be what we want to test whether it's inside the user input as well. So the problem is because of this here. Okay, so remember, hashtag means comment. The moment you start with a hashtag, everything afterwards will be regarded as comment. That means they are not code. They will not be executed. So if we want to include this, okay, include this, for example, we need this backslash. Okay, this backslash will make this as a character rather than as a comment. Okay, so let's run this now. Okay. So we have all the special characters that we need here, including the backslash itself. Okay. So including hashtag itself now, it's not as a comment, but as a characters. Okay. I'm actually gonna change it to here. And I make a mistake here. Okay. All right. So these are all the special characters here. All right. Good. So you're gonna write for X in special characters. So you don't have to play with this yourself anymore, already created for you. So these are all the special characters. All right, now I want to put a remark here. So to continue in the lecture, so in the lecture, we talk about this problem. Write a program to check password contains alphabets. Okay, so I'm gonna continue. And this is the code that we left off from today's lecture. Okay, so it's similar as before, as has digit. We first set has alpha to be false, and then we run through all the possible alphabets. If any of this alphabet is in password, we set as alphabet equals to true, and then we stop checking, we break it. And so at the end, if none of the alphabet from A to Z is in the password, is in this password here or user input, so then as alphabet will remain as false. Okay, but if you run this code, it says the password does not contain an alphabet. But if you look at this password here, which is initialized to this value here, it actually contains alphabet. Now, this attempt is, so attempt 1, wrong code. Okay, this code will be exactly or similar to what we have here, except the part that these alphabets here are small letters. Okay, small case or lowercase. But password, even though it's contains alphabet, it contains uppercase. All right. So which means we should not just check this, we also should check the uppercase as well. Okay. So wrong code. Okay. So we're gonna check. So for the text here, so the code is wrong because we are checking whether small case alphabet is whether they exist small case alphabet in password. when we iterate over all small case alphabets. Okay, so how do we fix this? Okay, so to fix this, so there are many options. So let's look at option 1. So we also need to check if there exists an uppercase alphabet in password as well. Which means we need to run another iteration over all uppercase alphabets. Okay, so let's do option 1, for example. Okay, run 2 for loops. 1 uppercase, 1 smaller case. Okay, so I'm gonna do this, copy and paste everything. Okay, so this one just to check whether there is small case alphabet, and now I'm gonna check whether there is uppercase alphabet. Okay, so in this case there are 2 options, of course. Okay. So option 1, I can write this as alphabet myself explicitly. As you can see, it's very, very tedious. I need to make sure all the alphabets in there. I did not write one alphabet twice and miss one alphabet, for example, and there are 26 of them. All right, so this is run. And it says now the password contains an alphabet. But you see here, it runs 2 for loops. 1 for small alphabets, checking whether any of these small alphabets in password. Second, checking whether the uppercase alphabet are in the password. All right. Now, can I do this differently? Okay, so it turns out instead of writing this explicitly, since you already have A, B, C, D, E, F, G small case, okay, so these are another options. So instead of writing it explicitly, okay, I'm gonna use the small case letter that I have previously written and change it to uppercase. So if you remember, there's a built-in function called upper. It returns a copy of the string converted to uppercase. So that's what you're gonna use it. So for example, I'm gonna do dot upper. Okay, remember it's a method. So you do dot to you apply it using dot method, and remember there's a bracket. So now I use the previous one that I have written. I just put dot upper. It will convert it to capital A all the way to capital Z without having me to write it out A to Z again, 26 characters. And this will give us the right answer. It will test 1 lowercase and 1 uppercase. All right. Now this is running 2 for loops. Okay. And if you know me, you know that I will always try to optimize this by not running 2 for loops. Okay. So 2 for loops means you run 26 times here, 26 times here. So in together 52 times in the worst case. In the case where there exists no alphabet in password, you will run 26 times here, 26 times here, so altogether 52 times when password does not contain alphabets, okay? Now, because then you never break it, okay? Now, option 2 is that can we skip 1 loop? Do we have to do 2 loops, okay? So notice that as long as an alphabet is in password, okay, then it doesn't matter. Then it is valid. It doesn't matter whether it is a lowercase or an uppercase letter. Okay, so what does it tell us? Is that I don't care whether it's uppercase or lowercase as long as it's in the password, we are good to go. So one thing we can do, so instead of running 2 for loops, one other option, we could, for example, we could convert password. We could check, for example, we could check whether a small case alphabet is in password lower. That means I don't care if this is uppercase or lowercase. I'm gonna create a new string, which is the same string as password, but with every letter becomes lower cases. And then all I need to check is whether the small case alphabet is in password.lower. Okay, so here's what I'm gonna do. So I don't want to check 2 for loop. So I just check 1 for loop. Okay, and I run to all the small cases alphabet. I check whether X is in password lower. So password lower. So what is password lower? Password lower is equals to password dot lower. Okay, that means it create a new password, a copy of the string with the value the same as password here, but everything changed to lowercase. For example, you can print it out and see what is password lower. Okay. See, this is the original password. And when I create a new string, a new copy of this string, and use dot lower, it create a string where every alphabet changed to lowercase now. Okay. Now, all I have to do is to check whether the small case alphabet is in this password lower. All right. So in this case, it is. So even though password is all capital, we only check small cases only because we check it, is it in password lower? So it say that password contains an alphabet. Okay. So this is option 2. So I write it down here as option 2. So option 2. Check if lowercase alphabets in password dot lower. Yes, this is option 2. This one is so I accidentally remove it. So this is option 1 where you run 2 for loops. Okay. Now, so this is the power of using built-in methods and also to analyze your objective. Your objective is just to check whether it has alphabet. We don't care whether it's uppercase or lowercase. And in this case, we instead of running 2 for loops, we only use 1 for loop. Okay. Now, let's also remember early on, we're also looking at this in the lecture. Okay. So remember has digit, when we improve the code, we use range to generate it without having to write out the digit explicitly and then do a cast conversion, do a type cast to convert into string. Now we wanted to do the same thing here. Is there a way to write 26 alphabets, A to Z, without having to explicitly write it down explicitly? So again, can we use range 26? But it generates integers, not alphabets. So how can we, there's no typecast it. We can't typecast it into alphabet. We need to be able to map integer to alphabet. So you will learn how to do this in the later part of the course. Okay, when we talk about character encoding, where every character is actually represented by an integer, and we're going to use that integer and use the range of the integers that represent A to Z in our code here instead of writing down A to Z explicitly. All right. So this is to defer. Okay, so improve code. Okay, improve the code using range. Can we do that? So this is to defer. Okay. Now there's another thing that I really want to talk about, which is a different way of writing this code. All right. So let's look at this here. All right. So this is our final code. Okay. So the above is our final code. All right. So analyze the code. All right. So if you look at this code here, so how many iterations are there? In the worst case. Okay. So in the worst case, we run 26 times. This is a for loop of 20. That first iteration, x value is A, second iteration, x value is B, third iteration, x value in C, and the last iteration, x value is Z. So in the worst case, where it never break, you never stop the iteration because there is no alphabet in the password, for example. So suppose it's just digit or punctuation marks, okay? With no password, with no alphabet. Okay, in this case, alphabet is never in password. Okay, also not in password lower, for example. So it never equals to true, it never breaks, so you run 26 iterations. Okay. Now, suppose you have this password here, it runs 26 iterations. But if you look at your password here, it only have 4 characters, 1212, 4 length 4 password. Okay, but you run 26 iterations here because you run to check whether all this alphabet is in the password. All right, so is there a way to reduce the number of iterations? So indeed, there is a way to do so. Okay, so if the length of the password is small, okay, we don't want to run 26 iterations in particular. This is not efficient. And not to mention, when you check whether X is in password, okay, in addition, when execute X in password or password lower, okay, we are running a search. We essentially running a search algorithm. Okay, and password lower is a string. Okay, and it's not a set, it's a string. So it basically trying to find whether X match the first character of password lower, whether X match the second character of password lower, and so on. So we run essentially running a search algorithm over the string over password lower. Okay. So basically we do a lot of for loop, not just 26 iterations. Inside this execution of X in password lower, we also have iterations in the built-in execution of this one here. So we don't want to do redundant for loop here or redundant checking here. So instead of checking whether each of this alphabet is in password lower, for example, we could make use of reverse the order. So we check whether each character in password is in alphabet, for example. So instead, so what if, so we check what if we, instead of iterating over all small case alphabets, okay, we iterate over the password, over the elements of the password. right? So how about we do a different way? So we're gonna do here. So instead of here, so for every x, instead of A, B, C, D, E, F, G, X, Y, Z, okay? For x in password now, for every element in password, okay? If x is in the alphabet or small case alphabet, okay? Try password lower, okay? If for every x in password lower, if x is in this string here, all right, then we know that it exists. Okay, has alphabet is equals to true. So let's check this. Say password does not contain alphabet. So the outer for loop here in for loop for x in password lower, you only run 4 iterations because password has only 4 length 4. So for x in password lower, the first iteration, x takes the value of 1. Second iteration, x takes the value of 2, and so on. And for each of these value of x, you check whether they are in alphabets. Now, is it better? Okay, so in the worst case, 26 iterations in the for loop. Okay. Okay, so we're gonna analyze this. So in this case, in this code, okay, the code, there will be 4 iterations in the for loop. Okay, in the for loop, they will explicitly written here. Okay, however, we also have how many? We also have checking here. We also execute this. We also have the following code where x in here. So this is the code that we check. Okay. Which also run a search algorithm over the string. All the small alphabets. Okay, 26 of them. All right. So essentially, we still run the for loop over here. We still run the iteration over here to check whether a particular x value is inside this string. And this string, if this is a string, so checking x is in the string, there is no efficient way except to match whether x is in the first character, x is equals to second character, and so on. Okay, so again, there will be 26 testing here to check whether x is in equals to A, x equals to B, and so on. So essentially, if you want to be more precise, it will be 26 times password lower times 4 here, and then 4, if the password lower contains length 4, it will be 26 times 4. So each of these 26 iterations, you check 4 times whether that match, because password lower has 4 characters. And in this case here, the same thing, you check 4 iteration here. At the same time, inside each of them, you also check 26 times 4 of them in the worst case. Okay, so essentially, if you use string, if you check whether x is in the string, these both code will have the same number of executions operations here. Okay, even though it appears that for the first for loop it has 4 iterations, and here in the first for loop it has 26 iterations, but altogether, if you count the operations run in here, it will be the same number of operations in both code. Now, can we improve it further? Can we make it? Can we improve the efficiency of this? Now, of course, you can, obviously. So here, instead of as a string, you can put it as a set. Okay, searching whether an element is in a set. is fast because the way the data structure created for a set allow it to do fast searching. Okay, so this will be out of the scope for this course. I just put a remark. So instead of, so essentially both codes, roughly speaking, runs equivalent number of operations. Okay, to optimize the code, to optimize the efficiency or the running time of the program, instead of using X in this code here, searching over the string. So we could use X in a set, okay, in alphabet set, where alphabet set is a set of alphabets equals to the set of all the alphabets that you have here. Okay. Okay. So set is a data structure that allows fast searching or efficient searching. All right. So you can do that. Of course, these are all out of the scope. I'm just telling you, if you want to repeat these statements so many times, you could create a data set called alphabet set, which is a set of all the alphabets. And efficient searching of a set is possible because of how the data structure is created. And so instead of writing S is in a string, we put X is in alphabet set, where we define alphabet set to be the set of all the alphabets. Now, these are all the extra informations for you to understand which version of code that you want to write. And sometimes it doesn't matter, as in this case. It becomes matter when you use two different data structure. So choosing the right data structure for your code is also very important. And that's all for today. Thank you, class.